All of you, please keep reading. What is the next concept? Illustration of Newton's third law of motion, or we can say applications also. Illustration of Newton's third law of motion. Later we will study what is the law, these applications of Newton's third law of motion. Okay, the real life examples and all. Now all of you keep reading. Illustration of Newton's third law of motion. That is what some examples I will give you. Later we will study it. Now, first example. Now you can see here. You can see in our textbook also, or else you can listen. So, for example, when a rubber ball is stuck against a wall, then what will happen, guys? When a rubber ball is stuck against a wall, the ball bounces back due to the reaction of what? Whom? When suppose I have hit the I have hit the ball with the to the wall. Now the ball after hitting the wall, it will be coming back, bouncing back because of whose reaction? Reaction of whom?
Wall.
Reaction of wall. Very good, Gokul. Reaction of wall. That is what. Now, when a person jumps out of boat, the boat is pushed away in the backward direction due to the what? Due to the what, guys? Reaction only. Understand? Now, illustration of third law of motion if we'll take. So in our textbook also, page number 66, they have given three figures. What is the three figures? Anybody can say? All of you see that? So page number 66, they have given some figures. So that is what all of you observe. So what they're doing, the person, one person is walking. So if you want to walk on the ground, is it possible to walk without the force or action and reaction? Is it possible to walk without action and reaction? Please respond.
No, sir.
No. You can see here, a man walking on the ground, so that you can see a force on the ground. He is trying to push the ground with his legs. With his legs, he is trying to push the ground in the backward direction. So that is why it is called as, what is that called as? He is trying to push the ground in the backward direction. So that is what we used to call as what? Force exerted on the ground is called as action. So when we are trying to push the ground in the backward direction, our ground, what it will do, Hari? Danishka, our ground will try to
show reaction.
Yeah, will shows reaction in which direction? Forward or backward? We are exerting force in backward direction. That is what we used to call as action. So ground will exert force on us in opposite direction. That is what we used to call as what? Reaction. Understand? So force on foot exerted by ground is called as reaction. So that is why we can say we can walk on the ground. Is it okay, everybody? Yes, please. Understand? Next one. Now you can see it is very difficult to walk on slippery ground or ice. Why, guys? Anybody can tell? Why it is difficult to walk on slippery ground? Because of what? Anyone? Why it is difficult to walk on ice or slippery ground? Anyone? You all people knows, guys. Please try to answer. What is the reason behind difficult to walk on slippery ground? Yes, please.
There's no friction.
Or ice, something is less, which we studied in 8th class. I only taught you. When if you are walking on the water or something, you can see something is less. That is what? What is that? Friction is less. Yes, very good. So here frictional force is less. Understand, everyone? So frictional force is less. So that, is it possible to exert more action force on the ground? Is it possible to exert more action force on the ground? So action is not possible. Understanding is not possible that much to exert the force on the ground. That is why ground also cannot exert the reaction on us, so that we cannot move or we cannot walk easily. Are you understand, everyone? Because of slippery in nature, I cannot exert. Do you understand, everyone? So we cannot exert a backward action force on slippery ground or ice, which would produce us a forward reaction for force on us. That is the reason it is difficult to walk on where? It is difficult to walk on ice or, understanding, slippery ground, because it is difficult to exert an action force. Difficult. difficult to exert action force, so that ground also cannot exert reaction force. Now, why it is difficult to exert an action force? What is the answer? What is the answer
Friction
behind?
is less.
Friction
Less
is
friction.
less because of slippery in nature. That is what you have to remember. Next, here you can see when we are swimming, always we people will try to push the water with our hands towards to our abdomen. Is it yes or no? Ready? You all people know swimming. Everyone? Danishka? So when we are trying to move forward, we have to push the water in the backward direction. So push up swimming on water is action or reaction? It is called
Action.
as action.
Action.
We are exerting the force or pressure. Now, because of that, when I try to push the water in backward direction, then water will push me forward. That is what push of water on swimmer, you can see. Okay. Push of swimmer on water action. Push of water on swimmer. That is what we used to call it as what? What is
Reaction.
reaction? Okay. Now, from this you can understand very carefully. Here you see action is acting which direction, Hari? Action is acting Vartini, Mitakshri
Backward then.
acting what? Backward direction, and reaction is acting in the forward direction. Now, swimming case, action is acting in the backward direction, and pushing is reaction is happening in the forward direction. Understand? So action and direction does not have particular direct upward or downwards or react. That is what we can say backward or forward. We based upon the force exerted by first body on second body. First body on second body, we used to call it as what? Action. And second body on first body, we used to call it as what? Reaction. That is what you have to remember. So it may be act upward or downward or right, that is forward or backward, doesn't matter. So this is what the first illustration of Newton's third law of motion. That is what when we are walking normally, when we are walking on the slippery ground or ice, or when we are swimming. Is it okay, guys? Yes, please respond. All of you. Do you understand?
It's
Yes.
sir.
That is what. So action and reaction forces are equal in magnitude, but they do not produce equal acceleration in the two bodies which it is acting. That is what you have to remember, all of you. So for example, gun and bullet you can take. Is it possible to produce the same acceleration? Suppose after firing, is it possible to produce the same acceleration? Velocity will go with a very extremely
sir.
high acceleration, but gun cannot go, even though its force is exerting same. Whatever the force we are exerting on the gun bullet, same force reversely, it will act on the gun and will hurt our shoulder also if you are holding the big gun. That is why you can notice it, even though it is, all of you observe, even though the force, if I fire the gun, the force is acting on forward direction, that is what action. So that the bullet can exert the opposite force on the gun. That is what we used to call it as reaction. So action and reaction does not have any particular direction. They may be act on any direction. Is it okay, Hari? They may be act on any direction, but the acceleration force exerted by action and reaction force is same. Action and reaction force is same, but something is not the same. What is that? Action and reaction is same, but it won't create same acceleration on both the bodies. Is it okay, guys? Won't create.
Yes.
Is it okay, everyone? Create same acceleration on both the bodies. Please note it down, because one body may heavier, or another body is what? Or lighter. Okay, so that is what we cannot predict it. So either they can produce more acceleration or less acceleration. Is it okay, Mitakshri? Arun Kailash, please respond. Everybody?
Yes, sir.
That is what. So we
Yes,
cannot
sir.
predict it, either it is exerting more force or not. We cannot make it. That is what you have to understand and you have to make it. Everybody do it fast. Is it okay, guys? Everybody? So this is
Yes,
what
sir.
you can make. So we are having so many examples. Even gun. When we fire the bullet, gun will come and will hit your shoulder back. Like same way rockets and as well as boat and ship and as well as hose pipe and even horse pulling a cart. These all the things are examples of illustrations of Newton's third law. So these all the things that we will discuss in tomorrow's class. And tomorrow's class we are going to study the very important one. So that is what conservation of momentum. What is momentum? We studied in the last class. What is momentum? Momentum is equals to what? Equals to mass into velocity. So
Mass into action.
the momentum we are going to conserve it. That is what conservation of momentum it will come. So that is what we have to learn it, and derivation is also very important. Based upon this only, so many numericals will come. These all the things we'll discuss in the tomorrow's class. Okay. So with this I'll leave it. Thank you all of you. We'll meet in the tomorrow's class. Bye everybody.